Hello, my name is Ale Bagan. I am going to present the presentation for the Project 3 uh, path routing, Treadis path routing project for computer networks. So first off, here's the Jupyter notebook where first thing that I do is install a library that is going to help me visualize the graph that we were given as an example. Here I am exporting the necessary packages that I need. So I am putting two for the visualization and one that's going to help me for the implementation that I did. So what I did then is create a adjacency list, which is a way that we can represent the graph in code. As we can see, we have one, two, three, and how it's connected. We can see that one is connected to two, and this is the way that it has. One is also connected to four, and this is the way that it has. So I know that one and two is not helpful for us because we can interpret it. Uh, so that's why they created a no label. So in case that we wanted to see it as it was in the graph, for example, one being Washington, two being California one, and three being California two, then now we understand that Washington is connected to California one, and this is the cost. Yeah, and this is just basically creating the visualization. This is also data points that we can use. It doesn't have any meaning, but it just helps us to putting it in a plot. Yeah. So as we can see, here is the visualization I was talking about. So we can see that we have New York, the cost, and all of it. Yeah, perfect. Finally, the implementation that the project that I did focus on is on the Jigsaw implementation. The Jigsaw focuses mainly on finding every shortest path from a single source, but with a slight modification, we can find the shortest path from a source into a destination. So if we can see, if I go here and show the circle code real quick for our implementation, we can see the steps very clearly here. And the first thing that we do is initialize what we need, which is a priority queue. This is what's going to hold the data, the nodes for the nodes, the weights, and the paths that we're going on. A set which is going to be used for if we visited the set or not. Then we add the source to the initial path and the priority queue, and then we start loop. What we mean when we start the loop is basically while the priority queue is not empty, then we want to extract our current node, our current class, and our current path, and just first check if the current node is not in the visited set, because if it is visited, then it means that we already found the shortest path from the source to this current node, so we can just continue and skip this iteration. If this is not true, then we can just add it here to the set, and at this point, we know that the current node is at the shortest path from the source. Then we check if the current node is actually the destination that we want, and if it is, then we just return the current path and the current cost. If it isn't, then we need to add the neighbors and all the costs to the priority queue. And the workflow is if the neighbor that we are currently seeing is not in the visitor set, then we add a new cost, add it to a new path, and then add it to the priority queue. And this just keeps the loop going. And at some point, if the priority queue is empty, then that means that we didn't find a path from source to destination. So just we return an empty path and a zero as a cost, which technically we didn't add. Let me show that real quick in the code. So as we said earlier, we create a set that is going to hold the nodes that we had visited, a heap which is going to hold the current node, the current path, and the current cost. Then we start the main loop where we go and pop the current way, the current node, and current path. We check if the current node isn't seen. If it is, then continue, add it to the set. If the current node is destination, then we just return the current path and the current way. If it's not, then we're just going to do a loop and add all the neighbors from the current node to the priority queue. If it's not in the scene set, we're going to update the cost, the weights, and update the path. And here's basically the test that we were given for the instructions, where there were three test cases from New York to California 2, from Washington to GA, and from California 1 to New Jersey. And then we print those out, and here it is. So we see that from New York to CA2, we have New York, PA, Illinois, NE, Utah, California 1, and California 2 with a cost of 3,750. And then we see the other tests here. So I also added this uh, code so we can visualize what was the path that we took for the first test case. And then we can see that from New York we went to PA because we have a 300 weight. So we take this one. Then we go to Illinois. It's also 750. Then we go to NE 750, Utah 600, California 1 750, and finally CA2 600. So a total of 375, no, 3,7550. Yeah, so that will be all for my implementation for the priority. Thank you.